Val and I did our statistics study on what proportion of drivers text and drive. The topic was chosen because it's an interesting topic and can hold the attention for data and research to be done. It's important because it can show teens and fellow...
Mr. Gary Roberts, dial extension 5561. Gary Roberts, dial extension 5561.
and fellow students how realistic the problem of texting and driving actually is. We recommend that someone else do the same study so that we will have data to compare ours to. Our guess for the p-value is 0.21, and the reason behind that is many young and new drivers have been educated on the dangers of texting and driving and may be less likely to do so. We gathered our data by surveying students, teachers, and other adults with a one-question survey. The population was Newton High School students with licenses, and the sample size was 100, and our sampling method was stratified sampling. Our null hypothesis was what the proportion was equal to 0.21, and the alternative is that the proportion is not equal to 0.21. Stratified sampling, we chose that for our method because we excluded people that don't drive from our survey. We passed out 100 surveys during the lunch periods, and this is a picture of the surveys.
Mr. Gupta, if you're in the building, dial extension 5512 or come by the front office. Mr. Gupta, if you're in the building, please dial extension 5512 or come by the front office.
The pie chart with the data is that 63 people said yes, they do text and drive, and 37 said no.
Okay, for our data, our conditions, the SRS was stated. And it was normal because n times p is greater than or equal to 10, which was 100 times our proportion, which was 0.21. Our independence was the population greater than or equal to 10n, and our alpha was 0.05. We used that because that was our error, our room for error. And 0.21. We had a one sample z-test. So z equals p hat minus p divided by the square root of p times 1 minus p divided by n, which would lead us to z equaling 0.63 minus 0.21 divided by the square root of 0.21, 0.79 in parentheses divided by 100. And that gives us the z-score of 10.31, and since that would be off the chart, it would be approximately 0. Even multiplied by 2 would still be 0. So our p would be approximately 0. What went right in our survey was that we were able to get the entire sample size in a timely manner and easily.
Ms. Blank, if you're in the building, please go to your classroom. Again, Ms. Blank, if you're in the building, please go to your classroom.
What went wrong in our survey was our guess for the proportion was not what the data showed. It was actually the complete opposite of what we expected. Bias sources avoided, that students were asked from all grades and were asked individually and not with their friends. Bias sources not avoided was that me and Devyn both text and drive as well, as you can see. What would we do differently? I would suggest that the population actually be observed while driving versus a survey. Type 1 error is if we reject H0 consequences, we believe that the proportion is actually larger or smaller than as hypothesized. And type 2 would be failing to reject H0 and we weren't supposed to, and people would believe students may or may not be driving safer than as hypothesized. Our conclusion would be to reject the H0 because P is less than 0.05 and conclude that the proportion of students who text and drive is not equal to 0.21.